In the vast expanse of the cosmos, one celestial giant stands on the brink of an explosive transformation. Betelgeuse, the red supergiant star in the Orion constellation, is captivating the attention of astronomers and stargazers alike. But why? Join us on a journey through space and time as we explore the staggering size, evolution, and impending destiny of Betelgeuse. From the great dimming to the potential creation of a black hole or neutron star, this is the story of a star's supernova illuminating our night sky like never before. Betelgeuse, a star on the brink. Betelgeuse, a celestial giant situated in the Orion constellation, is a red supergiant star. It holds a stature unparalleled, so much so that it absolutely dwarfs our Sun. In the vast tapestry of the night sky, Betelgeuse stands out prominently, distinguished by its reddish hue and its role as the Hand of Orion, according to ancient Arabic nomenclature. From its initial formation, the star evolved through the phases of stellar existence. Its current status as a red supergiant is a consequence of a journey that began with hydrogen fusion in its core. Over millions of years, the star's core transformed, embracing helium burning and giving rise to heavier elements like carbon and oxygen. This progression led to the expansive red giant phase that Betelgeuse embodies today. However, stars like Betelgeuse, despite their brilliance, face inevitable fates. As they near the end of their life cycle, the depletion of nuclear fuel triggers a series of events culminating in a supernova. Betelgeuse is displaying telltale signs of these late-stage phenomena, which means that the star is nearing the twilight of its existence. While pinpointing the exact timing of a supernova remains a challenge, the distinct alterations in Betelgeuse's luminosity suggest a celestial event of colossal magnitude may be on the horizon, and it is to be much sooner than what we thought earlier. But before we go down that lane, let's take some time to consider the challenges associated with such calculations and explore the star itself a bit more. The distance factor. The enormity of space is a captivating aspect of observing celestial phenomena, and Betelgeuse exemplifies this perfectly. Betelgeuse is positioned approximately 650 light-years away from Earth, which roughly makes out to be 6 quadrillion, 150 trillion, and 650 billion kilometers. For perspective, a quadrillion has 15 zeros. So, when we peer at Betelgeuse, we are essentially gazing back in time due to the finite speed of light. Light, despite its remarkable velocity at approximately 300,000 meters per second, requires significant time to traverse the vast expanse of space. In the case of Betelgeuse, the light reaching our eyes today began its journey over 6 centuries ago. This brings forth a remarkable paradox. The events we presently perceive in the night sky occurred many centuries prior. The light we currently receive from Betelgeuse commenced its expedition towards Earth during a time when the Renaissance era was dawning. With each observation of Betelgeuse, we are, in essence, delving into a cosmic time capsule, allowing us to unravel the story of a star from centuries ago. Betelgeuse's staggering brightness and size. In terms of size, Betelgeuse dwarfs our Sun. Were this red supergiant to occupy the central position in our solar system, its edges would extend far beyond the orbit of Jupiter. Betelgeuse's diameter is estimated to be approximately 1,000 times greater than that of the Sun, measuring roughly 1.2 billion kilometers or about 936 million miles. In terms of luminosity, the red supergiant shines with a radiance of over 100,000 times greater than that of the Sun. This luminous display is a result of its prodigious size and the immense energy generated within its core. Its brilliance casts a reddish hue across the cosmos, distinguishing it conspicuously in the Orion constellation. Our Sun, while significant to us, is, in comparison, merely an average-sized star. Betelgeuse, on the other hand, is one of the largest and most luminous stars known to humanity. Betelgeuse's life cycle and evolution. Betelgeuse's life cycle spans over millions of years. It all began within a vast, dense molecular cloud composed of gas and dust. Deep within this cloud, gravitational forces start to coalesce matter, forming the nascent core of Betelgeuse. Over time, the core gathered more mass, steadily growing into a young, hot star known as a protostar. During this phase, Betelgeuse was enveloped in an opaque cocoon of gas and dust. As it continued to accumulate mass, the core's temperature and pressure increased. Eventually, these conditions became conducive to the fusion of hydrogen atoms into helium. This heralded the star's entry into the main sequence phase, characterized by a stable equilibrium between the force of gravity pulling inward and the pressure from the nuclear fusion pushing outward. Betelgeuse spent millions of years in this main sequence phase, during which it primarily burned hydrogen at its core, sustaining its brilliance and maintaining stability. However, as the hydrogen in the core depleted over time, the balance between gravitational forces and pressure became disrupted. Subsequently, Betelgeuse's core contracted, increasing both the temperature and pressure. The outer layers expanded, and Betelgeuse transformed into a red giant. Its outer envelope swelled significantly. This was a prelude to the red supergiant stage. In the red supergiant phase, Betelgeuse underwent a dramatic transformation. The core further contracted and heated, leading to the fusion of helium and heavier elements, producing an array of elements such as carbon and oxygen. These fusion processes then go on to form even heavier elements up to iron. But unlike earlier fusion processes, iron fusion doesn't release energy but instead consumes it. The core, unable to support itself against gravitational forces, will inevitably undergo a sudden and catastrophic collapse, triggering a supernova explosion. The signs of instability and irregular behavior hint at the impending supernova. The only missing link in this equation is when. Betelgeuse's recent anomalies. To get some sense of a timeline, we must delve deeper into why Betelgeuse has caught the attention of astronomers and space enthusiasts. This all comes down to the Great Dimming, which is a significant reduction in Betelgeuse's brightness, a deviation from its usual luminosity patterns. The Great Dimming unfolded between October 2019 and early 2020. During this time frame, Betelgeuse's brightness noticeably decreased. This departure from its typical behavior was stark and easily noticeable even to the naked eye. Maybe even some of you noticed this while gazing into the night sky. One of the primary considerations of researchers was whether this dimming was a precursor to Betelgeuse's inevitable supernova explosion. You see, red supergiants like Betelgeuse go through fluctuations in brightness as part of their natural variability. Naturally, this event raised important questions about the star's present state and what it might signify for its future. Some hypotheses suggested that this dimming could be attributed to a vast outflow of gas and dust from the star's surface. Others theorized that it might have been caused by a massive cool spot on the star's surface, leading to decreased brightness. An international coalition of scientists featuring prominent figures like Kenichi Nomoto from the Kavli Institute for the Physics and Mathematics of the Universe embarked on a comprehensive investigation. Based on their findings, they argue that Betelgeuse possesses a smaller mass and radius than originally estimated and is in closer proximity to Earth than previously assumed. The team also posited that the recent significant dimming event was instigated by the presence of a dust cloud, a compelling revelation that adds a new dimension to our understanding of this stellar giant. Another group of astronomers led by Hideyuki Sayo at Tohoku University in Japan proposed a novel perspective on Betelgeuse's intriguing pattern of pulsation, which is a continuous oscillation between expansion and contraction, accompanied by fluctuations in brightness. Betelgeuse's luminosity waxes and wanes in a predictable cycle of approximately 420 days. Astronomers attribute this rhythmic brightening to the cyclic enlargement of the star's outer envelope. This discovery not only questions previous assumptions about Betelgeuse's size, but also underscores the dynamic and intricate nature of these celestial entities, inviting a deeper exploration of their enigmatic behaviors. And as predicted, or at least hoped, the dimming gradually subsided, and Betelgeuse's brightness returned to more typical levels. But this left us with more questions than answers about the star's end, the supernova's impact on the night sky. Dr. Stanimir Mechev, a distinguished astrophysicist holding the Canada Research Chair in Extrasolar Planets at Western University, emphasizes the extraordinary spectacle that Betelgeuse's imminent explosion will present. He claims that the event will elevate Betelgeuse to a magnitude akin to a full moon for a fortnight. This luminosity will be so pronounced that the star will even pierce through the daylight, defying the usual boundaries of celestial visibility. According to him, this cataclysmic event would momentarily outshine all surrounding stars. Night would transform into day for weeks, even months. The Betelgeuse supernova, with its extraordinary luminosity, would be visible from various parts of the world. People across continents would be able to witness this exceptional phenomenon, provided the skies are clear. Its brilliance wouldn't be confined to specific regions, but would instead grace the night sky on a global scale, predicting Betelgeuse's supernova. But now comes an even more important question. When will the star go supernova? While pinpointing the exact moment of such an event is challenging, researchers have presented various estimates. Factors such as the star's current stage, its rate of fuel consumption, and the intricacies of stellar evolution contribute to these predictions. There is the possibility that Betelgeuse's supernova might have already occurred. It's conceivable that the supernova event has already taken place, but its light has yet to reach us. This notion adds a layer of mystery, as we might be observing an event that occurred long ago, awaiting the moment when its distant echoes finally reach our telescopes. Theories and research regarding when Betelgeuse might go supernova are abundant, yet no consensus exists on the precise timing. Most researchers propose that Betelgeuse is still in its helium-burning stage, indicating a longer timeline before its supernova. Studies from Hungary's Konkoly Observatory and the collaboration led by Kenichi Nomoto from the Kavli Institute for the Physics and Mathematics of the Universe come forward in support of this perspective. But this is far from the only possible explanation of the star's fate. Another prevailing theory, which is supported by Dr. Hideyuki Sayo, suggests that Betelgeuse is currently in its carbon-burning phase, implying that the star might collapse within a few decades after exhausting its carbon reserves. Decades, not hundreds of thousands of years. The time difference is staggering, but what remains consistent is the assurance that Betelgeuse is indeed on the cusp of becoming the Milky Way's next supernova. Each prediction on the timeline is founded on meticulous observations, theoretical modeling, and the best understanding of stellar evolution that we currently possess. And our goal here is not to discredit one research in favor of the other. Impact of Betelgeuse's supernova on Earth. The possible impacts of Betelgeuse's supernova on Earth present both awe-inspiring possibilities and considerations for our planet's well-being. We already discussed how the night sky will turn bright and lustrous like the day, but things don't end there. One of the significant impacts would be the release of cosmic radiation, including gamma and X-rays, during the explosion. These high-energy rays could pose challenges to satellite operations, especially those in higher orbits around the Earth. While there are assurances that the sudden changes in luminosity will not affect our biosphere adversely, there are no guarantees in the matter. For now, all we can do is hope for the best. Will we know it when the star goes supernova? If you were wondering, will this be all over the news in advance? The answer is yes, but not as early on as, let's say, next week's weather forecast. But if you tune into the right channel, you won't miss it. This is because neutrinos and gravitational waves can provide us with vital early indications of a supernova event, such as the potential one involving Betelgeuse. Neutrinos are ghostly and nearly massless particles that are difficult to detect due to their weak interactions with matter. However, they are among the first particles to escape a collapsing star during a supernova explosion. In the case of Betelgeuse's potential supernova, the immense gravitational collapse of its core would release an enormous burst of neutrinos. These neutrinos would race through space at nearly the speed of light, making them the heralds of the impending supernova. Specialized neutrino observatories, often deep underground or submerged in water, are designed to detect these elusive particles. The burst of neutrinos detected by these observatories would provide astronomers with crucial information about the supernova's onset. This early warning system could give researchers precious advance notice of the supernova event, potentially a few hours before the light from the explosion reaches Earth. Gravitational waves are also important cosmic messengers associated with supernova. As the core of a massive star collapses during a supernova, it creates intense gravitational waves that propagate through the universe. These waves are like the ripples created when a stone is thrown into a pond, echoing the cataclysmic event in the distant corners of the cosmos. Advanced gravitational wave detectors like LIGO and Virgo are finely tuned to detect such gravitational waves. When a supernova occurs, the gravitational waves it generates would be detected by these instruments, providing a complementary method to confirm the supernova event and further refine our understanding of the processes at play during such explosive occurrences. Post-supernova, formation of black hole or neutron star. In the aftermath of the supernova event involving Betelgeuse, the fate of the star's remnants hinges on its mass and the specific dynamics of the explosion. The two potential outcomes are the formation of a black hole or a neutron star, each representing the extreme endpoints of stellar evolution. When a massive star undergoes a supernova, if the core left behind is exceedingly massive, typically over 3 solar masses, it may collapse further under its own gravity, forming a black hole. The gravitational forces become so intense that not even light can escape from the region surrounding this collapsed core, creating what is known as a black hole. In the case of Betelgeuse, if the remaining core mass surpasses the critical threshold, the gravitational collapse would create a singularity, an infinitely dense point, surrounded by an event horizon or a boundary beyond which nothing can escape. The creation of a black hole from the remnants of Betelgeuse would impact the local region of the galaxy and provide astronomers with an opportunity to study these enigmatic cosmic structures up close. If the core of Betelgeuse, although still massive, does not exceed the critical limit for black hole formation, it could collapse into an incredibly dense object known as a neutron star. Neutron stars are composed mainly of neutrons, densely packed together, resulting in a celestial body of immense density and gravity. Neutron stars are equally fascinating cosmic objects. A mere teaspoon of their material weighs billions of tons on Earth. The collapse of Betelgeuse into a neutron star would lead to a highly compact, rapidly spinning stellar remnant, emitting radiation across the electromagnetic spectrum. The intense gravitational forces would also create peculiar effects, such as gravitational lensing and time dilation, which would help us further unravel the fundamental nature of matter and gravity. The outcome, whether a black hole or a neutron star, depends on the precise core mass remaining after the supernova explosion. In any case, it will for sure advance our understanding of astrophysics and life cycles of stars, especially big ones, one way or the other. Scientific understanding and funding. While in many ways Betelgeuse remains an enigma, it holds immense importance in the realm of astrophysics and space exploration. The cosmos is a vast and complex tapestry of mysteries waiting to be unraveled. Each celestial event, including Betelgeuse's potential supernova, presents an opportunity to deepen our understanding of the universe's fundamental workings. Scientific research allows us to grasp the fundamental principles governing the universe. It provides insights into the birth, evolution, and demise of celestial entities, helping us comprehend the grand cosmic narrative. The potential supernova of Betelgeuse isn't merely an isolated event, it's a page in the ongoing story of the cosmos. By studying it, we can refine our understanding of stellar life cycles, the behavior of matter under extreme conditions, and the consequences of cataclysmic events. Additionally, scientific research often leads to unexpected discoveries and breakthroughs. The exploration of Betelgeuse's supernova might uncover new aspects of astrophysics, refining theories, and challenging conventional wisdom. Thus, it's vital to continually invest in scientific endeavors to push the boundaries of our knowledge and explore the unknown. Curiosity is a driving force behind scientific progress. Humanity's innate desire to explore and comprehend the universe has led to remarkable advancements. Events like Betelgeuse's potential supernova captivate the imagination and curiosity of both scientists and the public. The allure of the unknown propels us to invest time, resources, and intellect in investigating such phenomena. Encouraging curiosity, especially in young minds, ensures a continuous stream of future scientists and researchers. Curiosity fuels the passion to explore and seek answers to the most profound questions. laying the foundation for future breakthroughs. Investments in space exploration have far-reaching benefits beyond astrophysics. They drive technological innovation, create job opportunities, and foster international collaboration. Funding must be sustained and increased to facilitate more ambitious space missions and research, promoting a deeper understanding of our universe and fostering a sense of unity and cooperation among nations. The potential supernova of Betelgeuse serves as a reminder of the incredible potential for discovery that lies beyond our atmosphere. It calls upon humanity to nurture its curiosity, invest in research, and unite in the pursuit of knowledge, ultimately propelling us into a future where we comprehend the cosmos in ways previously unimaginable. Thanks for watching. Don't miss this video you see on your screen right now. It's truly unbelievable.